Okay, hi guys. We had a little technical difficulty. The equipment stopped working, so I stopped after 4D. So now I'm just going to go on and do 4E. I was going to do F before, but that's okay. Okay, so number 4E. Yay, it's working. The E's a little bit not all there, but that's close enough. 4E. Okay, you've got two sets of data. You've got the before and the after. And there's some scratch work that you have to do before you can get started. And the scratch work is to find the differences of those numbers. One possibility is to put the befores in list 1, the afters in list 2, and then ask the calculator to do the subtraction for you, or you can just go ahead and do the subtraction. So let's do that first. The D's are the differences. So 70 minus 69 is 1, and the next one is 1, and then 2, and then 3, and then 2, another 2, a 1, a negative 1, a 6, a 7, and a negative 2. Okay, and we need to get certain information about that set of data. The first one is N. Well, let's just tell you how to start. You're going to push stat and then enter. And we're going to put the D's in L1. Or as I said before, you can put the befores in L1, the afters in L2, and then have L3 do the subtraction for you. You go up and you highlight L3, and then you say second L1 minus second L2. And then when you go to get information in a minute, you'll have to tell it L3. But I'm going to pretend that you put the differences in the first list, and then you're going to hit stat again. You're going to arrow over to calc, and you're going to hit enter, which is one variable stats. And at this point, if you hit enter, it'll use list 1. If you want it to use list 3, you have to tell it to use list 3. So I'm just going to say enter again. And then we'll get the stats that we need. First of all, X bar will give you D bar, which turns out to be 2. And S sub X will give you S sub D, which is 2.646, rounded to 3 decimal places. And then the other thing you need is N, which is 11. So degrees of freedom here is going to be 10. Okay, coming over here, it says, let me go back to the question. A test of writing ability is given to a random sample of students before and after they completed a formal writing course. The results are given below. At the 0.05 level of significance, test the claim that the course had no effect. Okay, and this is matched pairs. When you go to your formula card, it's the second one from the bottom in the Chapter 9 box, and it says matched pairs, because these are before and after of the same people. You wouldn't want the before of one person and the after of another person. Okay, so these are matched pairs, and right before matched pairs, it says 2 means. So what you're talking about here is means. In the book, they talk about mu sub D, but I like to call it mu1 and mu2. So if the course has no effect, that's going to be mu1 is equal to mu2, because if the course has no effect, the before and after will be the same. Some students think no effect means not equal to, but that's not true. No effect means equal to, because the before and after are the same. Okay, so that's going to be my HO. Mu1 is equal to mu2. And H1 will be that mu1 is not equal to mu2. Okay, the claim is in HO, so the magic word is reject. Remember, when the claim is in HO, you're just going to say the same thing twice. Whatever you do to HO, you'll say the same thing to the other ones. These aren't charging, but I'm not going to freak out about it right now. We're just going to keep going. Okay, we're going to draw the picture. You'll notice that the formula does start with T again, so it's a T distribution, and it is a two-tailed test. My markers aren't charging, but I only have a couple more problems to do, and I hope that I can get through them. Okay, and then we're going to have our reject HO on one side, reject HO on the other side, and fail to reject HO in the middle. Step 2, alpha is 0.05, and because it is a two-tailed test, we will once again divide alpha by 2. And if you remember, I told you that for problems A and B, I'm going to switch it. It's going to be different than the practice test. But C, D, E, F, and G will all be the same in the sense of they'll all be, well, C, D, E, and F are all two-tailed tests. And then G is a right-tailed test, but we'll get to that in a minute. Okay, so we have to go to T sub 0.025, comma 10. Remember we said the degrees of freedom was 10. So 0.25, comma 10 gives us 2.228. And so the critical value is plus or minus 2.228. So we get 2.228 over here and negative 2.228 over here. And so the sentence could be reject HO if T is less than negative 2.228 or if T is greater than positive 2.228. Step 4, the test statistic. Even though this is Chapter 9, this looks like a test statistic from Chapter 8 because we've condensed two sets of data into differences. So it's D bar minus mu sub D over S sub D divided by the square root of n. D bar is 2 minus mu sub D. Mu sub D, just like in the last one, is a 0 because mu sub D is equal to mu1 minus mu2 divided by S sub D, which is 2.646, divided by the square root of 11. Okay, when you do this on the calculator, first of all, ignore the minus 0 in the numerator. Just make it 2 divided by, and then make sure you put parentheses around the denominator. So it's 2 divided by parentheses 2.646 divided by the square root of 11, and that turns out to be 2.507. And if we look at our picture, 2.507 is larger than 2.228. So step 5, initial conclusion is reject HO. And then the final conclusion, again, remember when the claim is in HO, you say the same thing twice. So it's reject HO, reject the claim. Oh, my phone's ringing. Sorry about that. Excusez-moi. Okay. So now we're going to go on to problem F. And for problem F, we use the same data that we used for problem D. Unfortunately, if you print it off the internet, it might say E, but for F, you're supposed to use the information from part D. So this is for F. Okay, and again, we have the men, and N is 40, X bar is 79.8, and S is 6.8. That equal sign looks a little screwy, so we'll fix it. Okay, and then for the women, N is 50, X bar is 81.2, and S is 8.4. Move it over one more time because I don't like it. X bar is 81.2 and S is 8.4. Ah! Okay, I had a little bit of technical difficulty again, but we're back on with the green light. Don't know why it's so fussy. So X bar is 81.2 and S is 8.4. Okay, and this is the problem where it matters which is group 1 and which is group 2. So again, we pick the larger standard deviation, which is 8.4. So this will be group 1, and the women will be group 1, and the men will be group 2. Okay, and it says, using the information from part D, again, just to repeat because I'm not sure when I cut out here, if your version says E, that's wrong. It's using the information from part D. Test the claim that the populations have equal variances. Okay. So the claim is equal variances. The symbol for variance is the population symbol, because that's what we use when we're writing our claim, is sigma squared. So it's going to be sigma 1 squared is equal to sigma 2 squared. Okay, so again, HO is sigma 1 squared is equal to sigma 2 squared, and H1 is that sigma 1 squared is not equal to sigma 2 squared. The claim, again, is in HO. And so the magic word is reject. We're just going to say the same thing twice. Okay, now when we draw this picture, it's the last formula in the Chapter 9 box. I think it says 2 standard deviations or variances, some standard deviation or variance, 2 populations. It starts with the letter F. So we're going to draw a picture of the F distribution. The F distribution looks just like the chi-squared distribution in the sense that it's limited to the first quadrant and it is not symmetric, it is skewed. And this is once again a two-tailed test. It's kind of awkward to do with this one, but we'll work it out. Okay, so again, you have reject HO over here, and then get my eraser and make this a little bit shorter for me. You have a little, tiny little reject HO region right here, and then the middle, of course, is failed to reject HO. Step 2, alpha was not given to you. When alpha is not given to you, you assume that it is 0.05 divided in half is 0.025. Step 3, we're going to go to the F table to get our critical value, and it's F sub 0.025, and then it's degrees of freedom 1, degrees of freedom 2. So degrees of freedom 1 is 49, and degrees of freedom 2 is 39. The F table is not on your formula card. It is in the back of your book. It's table A5. I'm not sure what page it is because your book is a little bit different than mine because you have the student version. But it's table A5 in the back of your book. And in the back of your book, there's 4 pages. 2 pages for 025 and 2 pages for 05. But on the final exam, I only Xeroxed the 025 pages. So when you look at the table, at the top it says F distribution, alpha is 0.025 in the right tail, but we'll ignore that for right now. And it says numerator degrees of freedom DF1, and then it goes 1, 2, 3, 4, 5, 6, 7, 8, 9. And then to go higher than that, you have to go to the second page, which is 10, 12, 15, 20, 24, 30, 40, 60, 120, and infinity. So we have to pick the one that's the closest. So our degrees of freedom 1 is 49. So 49 would be closer to 40 than it would be to 60. So we've got 40 for degrees of freedom 1. And then down the left side is degrees of freedom 2, and that's 39. And 39 would be closest to 40. So it's basically 40, 40. So the critical value is 1.8752. 1.8752. And that happens to be the right critical value, 1.8752. And how do you find the left critical value? Well, it turns out here you just don't have to. I believe it's page 499 in the textbook where he tells you that because we are stipulating that the larger sample variance is sample 1, all one-tailed tests will be right-tailed, and all two-tailed tests will require only that we find the critical value to the right. So the sentence is, reject HO if capital F is greater than 1.8752. Still going uphill a little bit. Okay, step 4. The test statistic, capital F, the last one in the Chapter 9 box, it's S1 squared over S2 squared. And I want to point out right now, if you look at that formula and you look to the right of it, in parentheses, it says S1 squared greater than or equal to S2 squared. And you can take the squares off that, and basically what it's saying is S1 is greater than or equal to S2. So that's your little reminder that when you pick group 1 and group 2, you have to compare the standard deviations. Okay, so that's going to be 8.4 squared divided by 6.8 squared. So this will always have to be an improper fraction. The number on top has to be larger than the number on the bottom. And this turns out to be 1.5260. So 1.5260 would be over here. It's not quite large enough to reject. So step 5, initial conclusion, fail to reject HO, and then the final conclusion I'll put below it. In class we called this the ditto because you say the same thing again. Fail to reject the claim. So fail to reject HO, fail to reject the claim. Okay, things are charging again. Everything looks fine. And we've got one more problem, which is G, and then we'll be all done. So, okay, here we go, last one. Hopefully everything will continue working well for us. Green light is on. Okay, so this is for G. And I'm going to copy the chart here. We've got CH for characteristic. and that's A through F. A, make these a little bit longer here. B, C, D, E, and F. Too long. Okay, and the frequencies are 28, 30, 45, 48, 38, and 39. I actually do need a little bit more room here. Okay, this problem is from Chapter 11. We covered 3 types of problems in Chapter 11. And this is the type, these frequencies would be called O for the observed values. And now we have to come up with the expected values. And the formula for expected values is N divided by K, where K is, where K is equal to the number of categories. So we've got 1, 2, 3, 4, 5, 6 categories. So the denominator is going to be 6. But what is N? What is the numerator? Well, in order to find N, you need to total. You need to add up all of the data, because you had 28 pieces of data in one category. You had 30 in the next, 45, et cetera, et cetera. So if you add them all up, it adds up to 228. 228 pieces of data. What you're doing is you're spreading them out evenly among the 6 categories. So 228 divided by 6 gives you an expected value of 38. And it's the same expected value for each of these. The other type of problem we did had a different expected value, but this one's a little bit easier. Okay, so it says, in a study of the occurrence of genetic characteristics, the following sample data were obtained. At the 0.05, so that's your alpha, significance level, test the claim that the characteristics occur with the same frequency. So the claim is same frequency. Okay, for this type of problem, your HO, we use P's here for proportion, the proportion that falls into each category. So your HO is P1 is equal to P2 is equal to P3, and depending on how many categories you have. Here we have 6 categories, which is P6. And the H1, I'm going to put over here. And the H1 is in words, and it says if they're not all the same, well, it doesn't say that, at least one P is different. So HO says they're all the same, and H1 says at least one of them is different. Well, our claim was same frequency. So looking at these 2 choices, whoops, I lost my top. I'll find it in a minute. The claim is in HO again, and the magic word is reject, or the ditto. Okay, this is a chi-square distribution that I'm going to draw a picture of. And even though your gut may tell you that this is a 2-tailed test, it is in fact a right-tailed test. All of the problems in Chapter 11 were right-tailed tests. Got any stray lines today? Very interesting. Okay, so I'm just going to go reg over here because I didn't leave enough room, but reject HO there and fail to reject HO in the middle. Okay, step 2, alpha is 0.05. Do not divide alpha by 2 because it is a right-tailed test. Step 3, we want to go to the chi-squared table, sub 0.05, and coming back over here, the formula for degrees of freedom is k minus 1, and that's on the formula card right next to the test statistic. It's the first one in the Chapter 11 box. So it's 6 minus 1, which is 5. So we're going to go to chi-squared table 05 and then down to 5, and the critical value is 11.071, which we come over here and we write 11.071, and that is the critical value if you want. CV, you don't have to put that. And so the sentence would be, reject HO if chi-squared is greater than 11.071. Okay, step 4, the test statistic. Chi-squared is equal to summation, parentheses, observed minus expected squared over expected. So what we're going to be doing is we're going to be adding. We're going to be adding fractions. Oh, thought I only had 4 fractions. I've got more. Okay, I'm going to erase this and move it over a little bit. See if I can have a little bit more room here to hopefully fit it all in. Okay, step 4. Chi-squared is equal to, don't like my equal to sign, is equal to summation observed minus expected squared over expected. So we're going to have 6 fractions. The first one, the first observed value is 28 minus 38 squared over 38. The next fraction is 30 minus 38 squared over 38. The third one is 45 minus 38 squared over 38. And the next one is 48 minus 38 squared over 38. And the next one is 38 minus 38 squared over 38. And the last one is 39 minus 38 squared over 38. Again, I realized I just forgot to put the total up here, which is 228. And then when you add all those up, you get 228 also. Okay, I like this problem because we have a common denominator of 38. You don't really need to get your calculator. We can do some of this in our head. The first fraction is 28 minus 38, which is a negative 10. If you square that, you get 100. The next one is 30 minus 38, which is a negative 8. Squared would give you 64. The next one is 45 minus 38, which is 7. Squared would give you 49. 48 minus 38 is 10. Squared is 100. 38 minus 38 is a 0. And the last one is 39 minus 38 is a 1. Squared is 1. So that's all over 38. You're going to add all that up, and it adds up to 314 over 38, which is 8.263. And so 8.263 is short of 11.071. So step 5, initial conclusion, fail to reject HO. Final conclusion, fail to reject the claim. Remember, this is the ditto. When the claim is in HO, you're just going to say the same thing twice. So I was able to get the equipment to work. I'm very happy I was able to get through the rest of these problems. I guess that's it. Hopefully I'll see some of you tomorrow.